Okay, so we're back looking at number 44, which again is a quadratic function as it shows. So we're going to need this parent t-table again. And I identify that the a is equal to -1, which reflects over the x-axis. And then our hk is going to be -4, +3. And so making my t-table x plus h, ay plus k, that's going to be x minus 4, then -y plus 3. So again, I'm using the x values -2, -1, 0, 1, and 2. So -2 minus 4, -6, -1, -5, -4, -3, -2. And then making all the y values negative and then adding 3, -4 plus 3, -1. -1 plus 3, 2, 0 plus 3, and then back because they have that symmetry. So these are the specific ordered pairs that I want to plot. And I'll plot them on the grid. -6, -1, -5 and 2, -4 and 3, -3 and 2, and -2 and -1. So I can kind of see the x-intercepts here. They would just be approximations if I was just looking at the graph. So it looks like it's approximately, so I'm doing the x-intercepts. Approximately, I use those ones. Looks like -5.9, (0), and then also -2.1, (0). From the graphs, I'm just going to estimate. For the y-intercept, I'm going to plug in 0 to the equation. So going back there, I want to see that. Okay, so that's going to be 0, comma, and it's going to be negative, and then 4 squared plus 3. So that's going to be -16 plus 3, which is -13. So those are my x and y intercepts. I've already got the -4, 3 is the vertex. So the domain, range, minimum, maximum, and increasing and decreasing intervals. So here, of course, the domain is again -∞ to infinity. And our range is about the y values, and its y is, and we see that it's going to -∞. So it's less than or equal to 3, just in case that notation shows up on your test. I want you to have seen it. And then with the interval notation, we say -∞ until 3. So those are the same. And then for increasing and decreasing, I sketch my vertical line. The x5 of the vertex was -4. So -∞ to -4, then -4 to infinity. This really helps me write the increasing and decreasing. So on this side, I'm going up. So the increasing interval is -∞ until -4, which means the decreasing is -4 to +∞. Very cool. So right on, moving right along to question number 45. Oh, I love this question. It's just going to be, it's standard form. So right away, I know that 0, -7 is the y-intercept. So plotting that right here, that's the one piece of information I know, in addition to knowing that the a value is negative. So this is again going to be facing down. So remember, we use h is equal to -b over 2a when we have standard form. And standard form says ax squared plus bx plus c. So that will be, wow. In this case, I'm going to have negative, -6. So 6 divided by 2 times -1, -2. So h is equal to -3. Going to -3, I'm going to sketch my axis of symmetry. Yeah, of course I missed right there. And that's lovely. And now I plug in the -3 back to the original. So that's going to be negative. -3 squared is 9. So the negative comes after, so that stays negative. And then I have -3 times -6, positive 18, and then -7. So 9 minus 7, which is 2. So the k value is equal to 2, meaning the vertex is -3, comma, positive 2. -3, positive 2. And then to sketch this graph, I'm just going to use the symmetry. So this is 1, 2, 3 units away. 1, 2, 3 units away. The other side will help me. And la-di-da, sketched it. It's not perfect like this. And another thing that I could do is, now that I have my HK and I still have my A value, I could make that x plus h, ay plus k table. So now to analyze this function, I found the vertex. For the x-intercepts, again, I would be estimating. So my graph is not great. It was so wiggly. Let me see if I can zoom in there. I'm going to say my x-intercepts look to be about negative 1.5, comma 0 right here. And then this one looks to be about negative 4.5, comma 0. We've already got the y-intercept here. The domain is -infinity to infinity. And the range, again, we're pointing down to infinity, so -infinity until 2 for the range, which I could also say is y is less than or equal to 2. And then for the increasing and decreasing interval, going from -infinity, let me use these colors, going from -infinity until, what number is this? -3, and then -3 to positive infinity. So we're going up and then we're going down. So it increases from -infinity until -3, decreases, oh no, there's no space, from -3 to infinity. This has a maximum. The maximum value is 2. And then it doesn't have a defined minimum. Oh, did I miss something? Oh, is it 1-to-1? It is not 1-to-1. No. So you could be showing your work for this on a separate sheet of paper, or maybe your work is tidier than mine. Let's take a look at 46. So 46 is an intercept form. Remember, that's x minus r1, x minus r2, and there could be polynomials written in this form too. So we've got the a value is 1/2, and then my x-intercepts are equal to 4 and 2. And so in intercept form, I'm going to plot +2, +4. We look for the midpoint, right? Because like I used that symmetry on this graph, we're going to use the symmetry here. So it's very easy to see this time that it's 3. And that's going to be the x value of the vertex. If it wasn't so obvious, it's got this midpoint formula. So h from intercept form is r1 plus r2 divided by 2. Midpoint, add them together and divide by 2. So now that I've got 3, I have to plug that back into my original equation. So that's y equals, or I could say k equals 1/2, 3 minus 4, and then 3 minus 2. So 1/2 -1 times +1. And this is the hint in this form. So you can see, oh, that's rad. It's the same values, 1 and -1, but they're opposite signs. So this is a problem that has a hint. The hint in this other form right here was that these are the same. It's 1 times the number and 2 times the number, opposite signs. Here's the hint here. Yay, we love hints. All right. So multiplying those all together, I just get -1/2 is the K value. So that's negative like 0.5 right there. So I want to find the y-intercept, of course, because they asked me to find it. And also because I just feel like I want to know it. So my vertex was at 3, -0.5. And then these are my x-intercepts. So my y-intercept, I'm going to calculate that by plugging in 0. So that's going to be y equals 1/2 -4 times -2. -4 times -2 is +8. 1/2 of 8 is 4. And then I'll use that symmetry again in order to graph this nicely. So that's 4. That's again 3 units away. 1, 2, 3 over here. So now I've got a beautiful graph. I think that this is just a rogue point. I don't know how that got there. So looking to analyze this for increasing and decreasing, domain and range. Domain is the same as before, but this time the range points up. So this function has a minimum right here at -0.5. So the range goes -0.5 to infinity, hard bracket here. And then we could also write that as y is greater than or equal to -0.5, if that makes more sense to you. Then for the increasing and decreasing intervals, this is -infinity, this is 3, and then 3 to infinity. And so just tracing it, on this side we're going down, but then on this side we're going up. So the decreasing interval, I'll just say it here, decreasing, -infinity until 3. Oh, great. And then this side increasing from 3 to infinity. And this is not one-to-one. Quadratic equations are not one-to-one, and neither are absolute value. Very cool. It looks like we've got some more work finding the vertex, so that's great because that skill was pretty challenging and we just kind of breezed through it. So looking at 47, 48, and 49, I'm looking to see which form they're in. So 47 is standard form. So then I'm going to use h is equal to -b over 2a. 48 is an intercept form. So that's going to be h is equal to r1 plus r2 divided by 2. 49, hello, that's standard form. And that's going to be h is equal to -b over 2a. So it's really important on your note card to note the difference between the h's. So in vertex form, h is in the equation. And then in standard form and intercept form, there are 2 different formulas to find h. So that's a lot to remember. Let's take a look at figuring out number 47. So that's going to be -4 over 2 times -1. And that's a negative divided by a negative. It's going to be 4 over 2, which is 2. So see how I canceled out the negatives? All right, now I've got the 2, and the work to find k is always plug the h value in. And so that's going to be -2 squared is 4, plus 4 times 2 is 8, plus 7. So remember, here's the hint. Okay, the hint here. The hint. It's 1 times the number, so 4, and then 4 times 2 is 8. So it's the hint. Adding those together, you should have a positive and a negative. So I've got -4 plus 8, that's 4, plus 7, which is 11. So the vertex is 2, 11. Wonderful. So then looking at 48, in this case, we need to find R1 and R2. So remember that we switch the signs in the parentheses. So H is going to be -3 plus -9 divided by 2. -3 plus -9, we add and keep the sign the same, -12 divided by 2. Which is -6. So now I'm going to plug that into my original equation. So plugging it in here, I'm going to have 2, and then -6 plus 3, and then -6 plus 9. It would actually be better if I just wrote that as 2. -6 plus 3 is -3. And then -6 plus 9 is +3. And then again, that's a special hint for this problem. It's the same number, but different signs. So again, different formula. So different formula, different hint. And so multiplying those together, we get a negative, and it's all together going to be negative, well, 9 times 2, -18. So the vertex is -6, -18. Oh my gosh, I started writing the wrong number. All right, in 49, that's going to be -12 divided by 6, which is -2. Plugging that in, 3 times 4 plus -24 plus 8. That's 12 minus 24, so -12 plus 8, which is -4. So my final answer here, -2, -4. Beautiful. 50 through 51 say graph the cubic function. And so cool. I love cubic functions. Cubic functions have the different parent t-table. So our parent t-table for the cubic function, in case you forgot, is still going to be -2, -1, 0, and 2. And then we cube those values. So -2 to the third power is -8, -1 to the third power is -1. And then we end up with the same values on the other side, but positive. And again, we're going to say our A, H, and K. So A is equal to 1. H, K is going to be -2, -6. Switching it in the parentheses. So then I can make the X plus H, AY plus K table. It's really cool because you can use that for all of your functions. That can be written in HK form. So -2, let's see, -2. So this is going to be X minus 2, and then this is 1Y minus 6. So -2 minus 2 is -4, -1 minus 2, -3, -2, -1, and 0. So that's really cool. That's going to be my Y-intercept. And then -8 minus 6 is -14. So again, I'm using these Y values. -1 minus 6, -7. 0 minus 6, -6. +1 minus 6. -5. And then 8 minus 6 is +2. So I want to go ahead and plot all these values. So I can scroll down. It's going to bring the numbers with me, which is kind of neat. So -4 and -14 is off the grid. -3 for X and -7 for Y. -3, -7. -2, -6. -1, -5. And then 0, 2. And then this one was way down here. So we'll just kind of plot it. So connecting my dots. Oh man. I kind of want to try it again because I missed this dot, but it's just the computer screen. So your graph is going to look a lot better than mine, which is so lovely and wonderful. And so now that I've plotted those, I just want to write down that the y-intercept is 0, 2 in case I forget. So then looking at this, the domain is -infinity to infinity. And the range is very clearly going down to -infinity and up to +infinity. So I love that. It's -infinity to infinity. For the x-intercept, I know it's going to be like -0 something because it's supposed to be right in here. So for my x-intercept, I'll approximate it at -0.2, 0. And then I've got my y-intercept. And then this function will only increase or decrease. So this one, when I trace it, it's going up. So the increasing interval is -infinity to infinity. And the decreasing interval is the empty set. For 1-to-1, the answer for these functions is yes. So let's take a look at 51. So, okay, we've got a function here that's got a really interesting a. A is equal to -1/2. H is equal, HK, the inflection point is going to be 3, 4. So going to my grid, I'm going to make that x plus h, ay plus k table. So x plus 3. We have 2, -1, 0, 1, and 2. -8, -1, 0, 1, and 8. So -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. Okay. And now I'm going to do -1/2 y plus 4. So negative, so that would make it +8. Half of 8 is 4. 4 plus 4 is 8. And then +1, when I multiply by negative, half of that is 0.5 plus 4, 4.5, and then 4. And now it'll be -1/2 plus 4, which is 3.5. And then it will be, instead of 8, it will be -4 plus 4 is 0. So I found my x-intercept. Here it is. That's going to be 5, 0. Let me find the y-intercept right now since I have this lovely space. Plugging in 0 for x, I get -1/2 times -3 to the 3rd power plus 4. So -3 to the 3rd power is -27. And then these two negatives are going to cancel out. And I'm going to get half of 27, which is the decimal 13.5, plus 4, 17.5. So that's not going to be on the graph, but at least now I know. And I can start plotting these values on the grid. So 5, 0. 4 and 3.5. 3 and 4. 2, 3 and 4. 2 and 4.5. And 1 and 8. Okay, so I kind of got it. So I'm going to clear out this work that I did so that I can do the analysis. And I actually saw that I answered some of the wrong questions. So it says here, X-intercept, Y-intercept, great, increasing and oh, never mind. So for these ones, the domain and range, just like before, negative infinity to infinity. The X-intercept is going to be 5, 0. Love that. The Y-intercept is 0, 17.5. This one is always decreasing because the A value is negative. So the increasing interval is empty, but the decreasing interval contains all the numbers. And then, yes, this is 1 to 1. Now, what about listing the transformations? So I didn't remember to do that for these. So let's do the transformations now. So I can actually do the transformations based on the equation, not even the graph. So I use the A, which was 1, and then the H and the K. So that was -2, -6. So -2 on the x-axis means I move to the left 2. So this is left 2. That's all you have to say. Just how did it move from the origin? And the -6, that's down. So down 6 units. Right on. Now for 51, the A value is -1/2, which actually does two things. The negative reflects over x-axis. It's also called a vertical reflection because it reflects in a vertical, like visually, it looks like it was a vertical reflection. So I'll just say that. And then the half squishes. So this is also a compress by the 1/2 or a factor of 1/2. And then for the HK, this time the 3, that's positive. So I move to the right 3. And the K is positive also. So now I move up 4. So those transformations are just listing how A, H, and K changes the shape of the graph. I haven't graphed the parent on any of these, but yes, I can see here that I moved to the left 2 and down 6. That looks pretty clear to me. This one has the same shape as the parent because the A is 1. Here I can see that I have moved to the right. How many? 4. No, what, 3 and then up 4. Yes, I see that here because these are my other ordered pairs. And then I see that it's going the other direction. My arrow is pointing down where this arrow on the right hand side is pointing up. That's what it looks like when I reflect. And it does look a little bit squished. So hopefully you can see that. All right, looks like I've got to take a break.